Good morning, everybody. Today we are going to learn dip strike problems using orthographic projection method. You are all aware of the basics of dip and strike. Here I will just try to revise. Now this is a inclined plane and it is being intersected by two horizontal planes. One is this plane and the other is this plane, and you all know that the intersection of an imaginary horizontal plane with the bidding plane results in the formation of strike lines. So we have one strike line formed by the intersection of this horizontal plane with the inclined bidding plane, and then there is another horizontal plane with a height difference of h, and it is intersecting this inclined plane at this height. So these two red lines, they are the strike lines formed by the intersection of this inclined bidding plane with the imaginary horizontal planes. Now, due to intersection of this, we have the strike lines, and we know that the true dip directions are always perpendicular to the strike lines. So we have this direction as the true dip direction shown here. Everywhere you can have these lines parallel lines which will show the direction of true dip. Now in this block diagram, here this is another triangle in brown color which is in any other direction than the true dip direction, that is the apparent dip direction. And you can see here that in the true dip direction, this is the horizontal equivalent, this is the height between the two strike lines, height difference between the two strike lines, and the angle between the H and HE, that is horizontal equivalent, is always of 90 degrees, or it is all these two lines are always perpendicular to each other. Now as we move towards the apparent dip direction, the length of the horizontal equivalent changes, and hence the amount of dip will keep on decreasing. Now this is another diagram, just the same right angle triangle diagram, where you can see that I have drawn, this is the true dip direction, the dark triangle in black is the true dip direction triangle, and then you have got two triangles in the apparent dip direction, right angle triangles. Now here we have to remember that the true dip direction is perpendicular to the direction of a strike. So this arrow, it is perpendicular to the strike direction. Then the right angle triangle for the true dip direction has the minimum horizontal equivalent. We know that the distance between two parallel lines is the shortest distance, or the perpendicular distance. So as was here, so this is the distance which is between the two parallel lines, and that is in the direction of the true dip. Now as you move away from the true dip direction, the length of these lines increases, and hence the angle of dip would keep on decreasing. So as we move away from the true dip direction in apparent dip, the HE will increase, and so the amount of dip will keep on decreasing. So as we move from this direction, from the true dip direction, as you move away, the amount of dip will keep on increasing, and once you come parallel to the strike line, the amount of dip, apparent dip, would become zero. That is, along the strike lines the amount of dip is zero, and the bed would appear as horizontal. Now in these problems, or in these triangles, you can always see that H is always taken as the same. We do not change H here. For all these three triangles, H is the same, that is the fallen height, and H will always be perpendicular to the horizontal equivalent. Here this is perpendicular to horizontal equivalent. In all the three triangles, H is always perpendicular to the true dip direction. So these things one has to remember while doing the dip strike problems. So in the dip strike problems, we have basically three types of problems. In first case, the two apparent dips are given in amount and direction, and one has to find out what is the true dip. So like this is necessary because when you go to field, it is not always you are going to find the true dip along the road sections or wherever you are measuring. So at two places you find out the apparent dips, the amount and their direction, and then using this orthographic projection you can always calculate the true dip direction. So here we have, what we have done is, we have first of all marked the direction of the true dip. If apparent dip 1 is 30 degree west of south and apparent dip 2 is 20 degree east of south. So these two directions have been plotted, and in this apparent dip 1 the amount of dip is 20 degrees. So we have drawn a line marking the angle bit of 20 degrees. So first of all draw the direction lines, then draw apparent dip directions and apparent dip amounts in respective directions. So this is 20 degree here, and here in apparent dip direction 2 the amount is given as 30 degrees. Now we have got two lines, ones with arrows, or these are relatively broader lines. They are representing the directions, or they are the direction lines, and these two fine lines are the one without arrows. They are representing the angles of dip in respective apparent dip directions when these are projected on a horizontal plane. So now we have to reconstruct the right angle triangles in both the apparent dip directions. So here we take a suitable H, and as I told you, it will remain the same for all the right angle triangles. So this is a H which is suitable. You can take it according to your choice, and this H will now remain constant for all the right angle triangles which we are going to draw. So by drawing this H, we have completed a right angle triangle in the apparent dip direction number 1. Now taking the same H, we mark it perpendicular to the apparent dip direction 2. As I told you earlier, H is always perpendicular to the dip directions, whether it is true dip or whether it is apparent dip. Now so put it perpendicular to the apparent dip direction 1. Now we have fixed HE for apparent dip direction. Here in this triangle we have fixed HE. This is the HE from the center to this place. This is the HE for apparent dip direction 1. Similarly, this is the HE for apparent dip direction 2. Now we know that by taking the same H and putting it between the angles made between apparent dip 2 and its corresponding angle of dip, keeping in mind that H is always perpendicular to the HE or the direction. This already I told you. So by doing this, we have reconstructed right angle triangles for both the apparent dip direction 1 as well as apparent dip direction 2. Now we know that the strike line passes through the point of intersection of HE and H. As was seen here, the strike line passes through the intersection of HE and H. So this is the strike line. Similarly, if you draw H here, the strike line will pass from this place. So we have taken these 2 points, and now when we join these 2 points, we reconstruct, or we are able to draw the strike lines. Now once you know the strike line, you know the direction of true dip, because keeping in mind the property that the true dip is always perpendicular to the strike line. So we draw a line perpendicular to this strike line, and this will give the direction of the true dip. In this case, say around 12 degrees east of south. The apparent dips were given earlier, so in using those we have reconstructed, and the true dip direction has been. So once we have determined the direction of true dip, like it is say 12 degrees east of south, the next part is to determine the amount of true dip. Again, we have to reconstruct the triangle for the true dip direction, keeping in mind that the h will be the same and h will always be lying perpendicular to the direction line. So from this point where we have the intersection of the strike line with the true dip direction line, we mark h perpendicular to it and then draw a line from the center joining this point, and we have reconstructed the triangle, and this angle will give the amount of true dip, say 42 degrees. Now one thing you have to remember, that true dip has the maximum amount of true dip. So maximum amount of dip is in the true dip direction. So you can see that this amount of apparent dip was 20 degrees, it was 30 degrees, and here the amount comes to around 40 degrees, which is more than the apparent dip directions. Only in one case, if the apparent dip is given in the direction of true dip, then the apparent dip would be equal to the true dip. Otherwise, true dip can never be less than any of the apparent dips. So we have completed this exercise where we have determined the true dip in amount and direction using the given apparent dips in amount and direction. Now we are going to do another problem where we know the true dip in amount and direction, and we have to determine the apparent dip amount if the apparent dip direction is given. So in this problem we are taking a case where the direction of true dip is south and the amount is 40 degrees, and the given apparent dip direction is 25 degrees east of south, and we have to determine the amount of apparent dip in this given direction. So again we have here we have reconstructed the right angle triangle for the true dip direction. You can see that the direction of true dip given was south. So if the true dip direction is south, the strike line will always be perpendicular to it, and we have drawn a strike line parallel to the east-west line anywhere cutting this south direction line, and so this is a strike line for the true dip which is south. Now we have to reconstruct the right angle triangle. So we know that the amount of true dip is 40 degrees, so we make a line here, and wherever this line cuts the strike line, this gives us the h, and h, as we know, is perpendicular to the HE. So this is the HE for the true dip direction, and this is right angle triangle, and you have the h. So we have reconstructed the right angle triangle for the true dip direction. Now the second part which is given is the direction of apparent dip, which is 25 degrees east of south. So we draw this direction, and now once you draw this direction, what you are doing is you are drawing the HE for the apparent dip direction. We know that the HE is the distance between successive strike lines. So for this any apparent dip direction, the HE would be lying between these point of origin and this strike line. So, and this distance is more than the perpendicular distance, as was the case with the true dip direction. Naturally, this amount, and then what we have done, we have made h perpendicular to the direction line or the HE, and then we have reconstructed this right angled triangle, and since the HE is more than that was for the true dip direction, naturally this amount of apparent dip would be less, and you can measure it, it would be say around 35-36 degrees and would always be less than the true dip. So we have determined, we have been able to find out the amount of apparent dip for the given apparent dip direction, that was 25 degrees east. I hope you are able to understand this. Now going further, there's another problem where the true dip is given. We will be taking the same true dip amount and direction, that is 40 degrees would be the amount, and the direction would be south, and then we have been given the apparent dip, which we'll see, and our objective would be to determine the apparent dip directions. We all know that for any apparent dip there would always be two directions of dip. So here the amount is 40 degrees, direction is south, and the apparent dip amount given is 30 degrees. We have to find out the directions of the apparent dip. So what we do, draw a line in the direction of true dip as was done earlier, mark an angle of 40 degrees on either side, either this side or this side, mark a strike line perpendicular to the true dip direction. This is the strike line. This will result in drawing of right angled triangle for the true dip. This was what we had done earlier. Now here, by doing this, we have fixed the H, which is, as I told you earlier, perpendicular to the horizontal equivalent for the true dip direction. Now we will be taking the same H for drawing the right angled triangle for apparent dips, for apparent dip which is 30 degrees. So separately here we draw a line on which the horizontal equivalent will be lying, and we take the same H as was taken for the true dip, and knowing that the apparent dip is 30 degrees, we draw an angle of 60 degrees here, and this will result in giving us this angle of 30 degrees. So for 30 degrees you can see that the amount of horizontal equivalent is this distance, and naturally this distance would be more than the HE for the true dip, because for true dip the amount was 40 degrees, and since the amount has decreased, naturally the HE would increase. Now we measure this HE using a compass, and from origin mark two arcs on this strike line. So on this side mark the point would be here, and here this is the point of intersection, and by doing this we have drawn, we know that this is the horizontal equivalent for apparent dip direction 1, and this is the apparent dip direction 2, and by doing this we can now measure this angle, and it will give the direction of apparent dips, something so say 60-65 degrees west of south and 60-65 degrees east of south. So you know how to determine the apparent dip directions when the amount of apparent dip is given and the amount of true dip and the direction of true dip is given. Now there's another problem which we commonly do where the strike direction is given. So that is problem 4. So in this case we are taking strike as north-south, and then one apparent dip is given. So the amount is 25 degrees, and the direction of dip is 35 degrees north of west. So both the amount and direction is given. Our objective is to find out the true dip in amount and direction. Remember, the strike direction is given. So when the strike is given as north-south, naturally the direction of true dip would be perpendicular to it, either towards west or towards east. Now remember, here apparent dip direction is given as 35 degrees north of west. So we have drawn this as 35 degrees north of west. So one of the apparent dips is in the western direction. Naturally, as I told you, the true dip could be either in the western direction or toward the east. But since one of the apparent dip is lying in the towards the western side, the true dip has to be towards the western side. It cannot be towards this side, towards east. So once we know the apparent dip direction, so we can always say that the true dip direction is towards west. Now our objective is to determine the amount of true dip also. So for this we are plotting the right angle triangle for the apparent dip. So apparent dip direction, as I told you, is given, and for this apparent dip direction we have to take we have to determine the h. So this amount is 25 degrees. We have drawn this amount, and at the point where this apparent dip direction, it will cut the strike line, that will be the point from where the h would be drawn. So we draw a perpendicular line joining this line, and this determines the h for this given problem. So taking this h, we draw it perpendicular to the true dip direction, and by doing this, and then you join this from the point of origin, this point, and this will complete the right angle triangle for the true dip direction, and we can easily measure the amount, which is, say, 31 degrees. Remember again, the HE for the true dip is the shortest distance. This HE for the apparent dip was greater than this, so naturally this amount of dip would be always greater than the 25 degrees which is given here. So it is, say, around 31 degrees. So by doing this, we have I have tried to explain you how to determine the direction and amounts of true dip and apparent dips given the problems. So I think you will be able to understand. Thank you.